So there are some really strong parallels between Uniswap v4 and the Ethereum roadmap. I see the parallels here. I'll call this like a hook centric roadmap for Uniswap, whereas Ethereum has this like roll up centric roadmap. Uniswap has now a hook centric roadmap, and I want to get to that conversation, but I think we need to start there with the Singleton contracts. The Singleton design. Uniswap v3 and v2 and v1, I believe, all had this thing called a factory contract where Uniswap pools, Uniswap exchanges were spun out individually and they were all separate contracts. So if you made a new token and then you made a Uniswap pool to correspond with that new token, that is a brand new smart contract on Ethereum that is the same contract as like the USDC Ether Uniswap pool, but it's still a separate contract. And so a Singleton contract is something that's the opposite of that. Can you just unpack that a little bit more, Hayden? Like, what does it mean for everything to be under one contract?
Yeah. So, what it means is that we're duplicating the same code across a million different smart contracts, and that has a cost to everyone. And so, one cool thing about the Singleton design is it actually reduces, current estimates have it reducing the gas cost of pool deployment by about 99%.
Wait, what?
Yeah, so it goes from like, gas costs vary a lot, but you could imagine sometimes people pay when gas costs are high, like north of $1,000 to deploy a pool just in gas cost, and that same deployment would be something like $10. Again,
because you were just updating
really
a pre-existing contract.
Yeah, most of the code isn't being replicated. It's just like adding a little, adding a little thing, like making a little modification to an existing contract. It's not deploying an entirely new smart contract. So gas costs for deployments go down massively. That's sort of like one of the advantages. There were designs that actually did reduce the gas cost for V3, but in ways that slightly increased gas costs for swappers. That was sort of like this design a lot of people use where you like call out into like a library contract. But that's sort of like one of the benefits of Singleton. The other benefit is that when you can imagine like transactions that interact with multiple pools and have multiple interactions with multiple pools, a lot of what they're doing is they're updating like the same, like you can imagine like, let's say I'm doing like a multi-hop swap. I'm going like ETH to DAI to USDC or something. That actually involves like, routing ETH into the ETH DAI contract, then DAI is sent from the DAI ETH DAI contract to the DAI USDC contract, converted to USDC, and then USDC is sent back to the user. When you have everything stored in the same contract, those internal transfers don't actually need to happen, right? They're sort of like ephemeral. And Ethereum already today has a method of basically, if you are updating it, so one thing is that there's basically like less transfers happening under the hoods when you have like multi-step transactions or transactions that route between many pools. Ethereum has like this thing called a gas refund. It's super technical under the hood stuff, but might as well for those who understand this mention it quickly. Ethereum has a thing called a gas refund, which basically means that if you are updating something and then the same thing multiple times, is cheaper than basically updating different things. Because there's like that's easier on an Ethereum node essentially, and we'll get out of the weeds in a second. But there's the refund has like a cap, so basically there's like a limit to like if you update the same thing like 1,000 times, like the refund sort of runs out, and then you basically don't actually get any of the refund. So there's this new proposal called transient storage, which is slated for the next Ethereum hard fork, and that provides additional benefits where you can actually save on gas for things that are updating the same contract multiple times, well beyond the sort of refund, which was capped out at 20% of the sort of gas provided to the transaction. So there's sort of like additional gas savings kind of like on the forefront of the next Ethereum upgrade, which is kind of exciting.
Am I misremembering that? Was there some controversy about this particular Ethereum upgrade at all, or like you guys refresh me on that?
I think that like there was a desire. I think that it was like it's like a very obvious. I don't think there's any controversy around like the proposal itself. It's like technically very sound and like there's no real controversy around it. I think that there was like a strong push to have it happen in the previous hard fork, which didn't happen. In part because we thought it was like an obvious win for developers. There's many other projects that also want this and want to build on top of it and have come out in favor of it. But it ultimately didn't make into the previous Ethereum hard fork because there was there was a lot of other things happening in that hard fork. But it was sort of very non-controversially added to the most recent one because it's very far along and it's not competing with the merge. And so it's, yeah, it was kind of a little bit of like a day of drama on Twitter, but there wasn't really like, at this point, it doesn't feel controversial at all.